What's up, everybody? Isaac here with Civil Engineering Academy, jumping on real quick with another fun podcast episode. Thank you so much for those that support us. Listen to us on YouTube or find us on any podcast platform. We really do appreciate it. Excited to be with you. If you need help with anything to deal with your exams, the FE or PE, please check out our website, civilengineeringacademy.com. We even have stuff like study groups that you can join, practice exams, including an FE CBT exam simulator, stuff like that. So go check it out if you need help with your exams and things of that nature. Today I'm way overdressed, but that's okay. That's good. It's good to look good. But today I actually bring my brother Mark back on as a structural engineer that is neck deep into designing structures and elements that deal with all kinds of structural elements. I wanted him to come on to talk about the recent building collapse in Florida, the Surfside, Florida condo collapse that recently just happened on June 24th at about 1:30 in the morning. The 12-story building collapsed and it caused almost 100 people to die, which is very unfortunate and very sad. And they tried to rescue people. It was a big mess. But I bring Mark on to share his opinions about what happened, kind of the history of this thing, the reports that were written about it, and what can be done in the future so we can help prevent it. So this was a fun topic to talk about in terms of understanding the collapse itself. But this is something that's going to go in textbooks in the future for sure, along with all the other disasters that have happened in the past that you typically start studying as a student so that you can prevent them in the future. So with that, hopefully everybody can learn a little bit more today about the building collapse that happened in Florida. I know for me, it was an interesting topic to discuss and learn more about, and I think you will too. So we got to learn from the past and make things better in the future. It's a professionals, engineers, code of ethics to design things that are structurally safe and pay attention to the signs when things are failing and do something about it. So anyway, with that introduction, let's get to the interview with Mark Oakeson. It's coming right up. All right, what's going on, everybody? Welcome to another edition of a Civil Engineering Academy podcast. Mark, I bring you back on. What's going on?
Hey, bro. It's going great.
What's
Glad
new
to be
over
here
there?
again. Yep, it's good to be here again.
Well, we're happy you're here, and I wanted to bring you on to talk about our Surfside, Florida condos. It's been all over the news for some time now, but as a structural engineer that actually works on similar projects, things of this nature, I wanted to bring you on and maybe talk about, in your opinion, the things that happened at this condo tower collapse, because I think it's helpful to understand the properties that maybe concrete exhibits and still exhibits to give us warning signs before stuff like this happens, because this is a horrible thing.
Yeah, and so being a structural engineer, and I primarily deal with structural concrete in my career. Yeah, you hate to see these kind of things happen. Of course, first priority is consideration for the individuals that lost their lives in this horrible event that happened. But this thing happened it was 1:25 a.m. This 12-story building just collapsed, and it was June 24th that it happened of this year. And as of July 7th, they stopped the rescue operations, and then they changed it to a recovery operation. And then, searches for victims actually stopped back on July 23rd. They sifted through the rubble as much as they could to find remains and try to establish identity of any individuals that were lost in the tragedy. But yeah, just a horrible deal. It's really, Isaac, it's recognized as like the third deadliest structural collapse. So if you'll recall, it's a lot of case history. When you're taking your structural design classes, sometimes they bring up the old classics, structural failures. There's the Tacoma Narrows Bridge. That's always a fun one that everybody calls up. And
Yep.
There was the Hyatt Regency walkway collapse in Kansas City back in 1981.
I
Um,
remember studying that one, the mold
yeah,
shearing.
and there was a really old one back in 1860 that was a Pemberton mill where 145 people died. So,
Yeesh.
um, if you look at the history of structural performance, I mean, that's if you like statistically compare that, it's not so bad. But any incident like this is a tragedy, and obviously we try to avoid it, right?
Yeah,
With
I think
good
it's a
structural
horrible
design.
situation. Obviously, it's not good. I'm always curious about what they do when they investigate these kind of things. But before we maybe even talk about that, maybe we can walk through maybe how this was designed. I know they're calling these the Champlain Towers, and they were actually built in 1981 by a group of developers. Um, and we've noted this that as part of a three building complex, with each building constructed to 12 stories tall.
Yeah.
And these drawings were produced in 1979 under the UBC, or the Uniform Building Code. So how does that relate to maybe the way things might be designed today, in terms of that?
Well, back in those days, remember that ASD was the primary method of design. So
Allowable strength design.
allowable stress design, yeah. And so what you would do is figure what kind of stress a member, for example, a beam was capable of resisting. And then you'd back it off a little bit by using a factor of safety. Um, and it's still actually allowed today. Engineers can still use ASD to design their buildings. They have to stay within, I'd say, some more parameters than they used to. But nowadays everything is per strength design primarily, LRFD.
All
Um,
right. Load resistance factor design.
yes, which uses more of I'll call it a stochastic kind of an approach, more probability of failure kind of an approach where, and what I'm talking about, Isaac, where they use these
Hmm.
limit states, right, to figure out what the nominal strength is of a member, and then they back it down by a fee factor, right, depending on how
Yeah.
much, what the chances are of failure. Um,
And I believe the whole idea of that, though, is that we're designing a more economical design,
well,
um,
exactly.
with LRFD.
Yes, and so you could argue that because this was UBC, that probably there were some components that may have been designed more conservatively than maybe we'd have today. Um,
So, just talking about the codes, our understanding is that this was built according to the code that it was needed to be designed to.
yes, yes, and I haven't heard anything that. I mean, there's always that gets questioned. The design gets questioned when something like
Hmm.
this happens, of course, and it should. But everything that I've heard is that there's nothing, there isn't a smoking gun that says that this building, um, even though it was designed per the UBC of 1979, was not actually constructed per that code. Um,
Gotcha.
I don't think there was any shoddy construction. At least there isn't anything that was pointing to that. But I mean, they had lots of investigations. The concrete was actually exhibiting warning signs, just like it was supposed to. So there was some, investigations, structural investigations that were done, and they determined that the waterproofing layer at the pool wasn't sloped sufficiently, and so it would constantly, the water from the pool was constantly standing on that pool deck and just allowed to
Mm.
sit there. And concrete is porous; it's a porous material, and so it'll soak up water. We deal with that kind of issue on parking structures all the time in corrosive environments. You get the de-icing salts and those kind of things dripping off of cars. as they park into the parking structure, and then the concrete's porous and it kind of soaks it up. And then when it gets down to the reinforcing steel, salt, on steel is just, I mean, it's like a corrosion accelerator. It just really, really starts rolling.
It's not
And
good.
so this water, I'm not 100% sure if it was a saltwater pool. It could have been, which would have even worsened the situation.
Yeah, that would be good.
Yeah,
I don't
but
know either what kind of pool it was, but obviously water and whatever chemicals you've got in the water plus concrete, if it wasn't designed to try to resist that stuff, at least the best that it can, not that it totally
yeah,
stops it, but if you're not preventing it, it just accelerates it.
exactly. And
So,
it's those chlorides that really like just kill it. And so over the years, the water just kind of percolated through the concrete. It got to the rebar. It started corroding the rebar. And then everybody started noticing spalling concrete, right? So spalling concrete is where it just kind of pops off in chunks.
mm,
And when rebar rusts, it expands. And so not only does expanding rebar pop off concrete, which compromises the structural section, right? The cross section of whatever structural member is being damaged with the water, it compromises that, but it also takes away the bond, right, between the steel and the concrete. If you've noticed a piece of rebar, it's got little deformations on it, right?
yeah, and I've seen this all the time in like short little retaining walls and in like parking places or bridges, pedestrian bridges too. You can see concrete that's like falling off where you've got salt and water over time just wanting to corrode that thing. So
Yeah.
sounds like similar situation here.
Yes, and then not only does it like compromise that bond between the rebar and the concrete, but it also starts compromising the actual cross section of the steel, the rebar, right?
Yep.
And if you can remember back your concrete design class, Isaac, the area of the rebar is a big structural property, right?
Yes, it is.
As you're
True
going through
still.
your structural design. And so if that cross section of steel is compromised, then the amount of tension that steel can absorb is lessened, right? And so years and years of corrosion compromising the structural section there, it just and then the same dead and live loads that are continuously being imposed on that pool deck. I mean, it just eventually it starts sagging, right? They see the spalled concrete, the structural members start sagging and giving you the warning signs, which that's what they're supposed to do. And if nobody reacts in time and makes those structural repairs before something bad happens, why we kind of get what we had at Surfside, Florida, going on.
We mentioned the warning signs that happen, and those are kind of built into our, to the design process. But with this particular one, there were investigations made. Sounds like there were some reports made a few times with some suggestions on what to repair and what to do and the cost of that. So,
Yeah.
what did you discover on those reports that were developed for that? When did they come out with those?
Well, I from what I've read, it seems to me that there was enough investigations going on, at least structural investigations. I would say competent structural investigations that were going on because of the alarming nature of the impending collapse that was there. But what I would think what happened here is that it was kind of resistance from the ownership, right, of the condominium. They're looking at the repair was assessed at about $15 million, which is a big nickel on a condominium of this size. And it was also going to impose a huge I don't know, it was going to be a big imposition on the residents of this condominium. They were going to probably get displaced for a little bit. I mean, to make repairs like that, you have to displace, first of all, everybody from the parking garage area, that deck that was supporting the pool. Get everybody, that nobody could park down there. There was probably good structural integrity in the tower itself. So they would have had to have displaced everybody down below. And I'm not sure what other spaces were below grade down there.
Hmm.
But it was just a big inconvenience, right? So you've got this structural failure that's about to happen. The concrete is exhibiting warning signs, telling everybody it's going to happen. We got to make the repairs. You've got a reluctant owner that's kind of like, man, this is going to cost a lot of money. It's going to displace all my tenants. This is going to be a pain. I don't want to deal with this. And so there's just kind of a reluctant, process. It's slow to get started and they just didn't get after it quick enough. But they should have gotten everybody out of the parking structure below. They should have got that whole deck shored up with some big heavy steel shoring. And they should have started the structural repair before all this happened, but hindsight's 2020.
All right. So I'm just curious. With hindsight being 2020, though, what could be done to avoid this in the future when someone else does an investigation of a property? Maybe it's one that's already right there in Florida. Maybe it's next to this one. Who knows?
Yeah.
Where the next one is going to be. But would you recommend not only doing an assessment like they did, but it sounds like really what needs to happen is just that action needs to take place a little sooner than
Well,
what was discovered. So.
yeah. So when a structural engineer makes an assessment, a competent structural engineer makes his assessment and gives you the warning. I mean, as a property owner, you ought to take it seriously. Is what this means. And yeah.
Well, in terms of timeline, though, Mark, the information you're sharing, I think, was from a 2021 report, but they had a report back in 2018 that kind of identified the problem back then.
Yeah, but they still hadn't put a price on what the repair would be, right? So I got to believe they got the report, and then the owner was a little bit reluctant in reacting, right, to the report, and he thought, man, I guess we better get some estimates done from some construction and some repair type contractors that can help us with this problem. And he just didn't know. I mean, in his defense, he just didn't know what the magnitude of the repair was going to be, which I'm sure is why he was a little reluctant in because assessing a repair like this, I mean, it takes a while just to make the assessment, right? You can go underneath and see that the pool deck is sagging, but it's a whole nother thing to have an official report done where a structural engineer makes a full investigation. I mean, he has to take measurements. There's some of those measurements take time to make, right? If he's starting to measure deflections over a certain time period, maybe he's putting strain gauges on different things and trying to make all his measurements. I mean, that takes some time too. And so I think it just took time. The wheels were slow in turning all of this. And then an owner's not going to want to make a decision until he has a price in front of him, but he can't get a price generated from a competent contractor until the structural assessment is done and the scope of the repair has been defined, right? So it just takes some time to get all that put together. So unfortunately, what should have happened is they should have gotten everybody out from under there, like I said, before any structural repair had to happen, and they should have got that pool deck shored up so that it could have resisted some additional load and not failed like it did. They could have shored that up before it all came down and bought them some more time to maybe put some numbers on the repair costs and kept everybody safe. In hindsight, that's what should have happened. But
Well, it's all unfortunate. These cases are obviously going to be in some textbook in the future as something to learn from. But it's always interesting to hear how, what's going on in the current events of today, how these things are investigated. I'm not sure. I mean, Mark, how do they investigate these things
Well,
to really find out what happened? I know you have these reports, and I think they're probably
yeah. So
lucky they have them.
before the building falls down, it's relatively easy, right, to do a structural assessment because the building's up, right? You can make your measurements. You can take your surveying shots. You can uh, you know paste your strain gauges in key locations. All those things can happen, but post collapse, man, it's tough because you're dealing with just a pile of rubble and twisted rebar. And I mean, you can go back and you can like see maybe if rebar, like the number of bars or, on a structural member, a column, or maybe a shear wall, that maybe the number of bars was there. But man, after everything's come down,
You're
it's
just
just a
hosed.
pile of powder. I mean, think about the 9/11 collapses, and that was a structural steel building, and the floors uh, were concrete. I think they were composite decks on that one, and so you can see just the pile of rubble. So it just kind of rubbleizes the concrete. It almost turns it to powder when it's enough of a force that it just compresses that concrete so much it grinds it to a powder. And so in that mess, in that pile of rubble,
Good
it's just
luck.
tough. It's tough to make a structural assessment. So the most valuable thing they've got is like the footage. They've got some security camera footage of how the collapse started in the center of the building, and then there was a section behind the center of the collapse, which was like a shear wall. Once that pulled away, then there was nothing linking that east tower to the west tower, and then it just came down as well because
Makes sense.
it just toppled over. But the short answer is it's tough after a building's already come down to make an assessment. It really is.
Got it.
So
Well, this has been very insightful for me. Obviously, there's news reports about it, but about it. But it's always fun to hear when somebody's in the trenches and doing and designing this stuff. How you hear about it and what your assessment is of the whole thing. So
yeah,
that's what's fun for me to talk about. It's a very unfortunate event. Like I said, I'm sure it'll be studied for a long time and thrown in a textbook somewhere in the future. So
yeah.
um,
That's just my assessment. I haven't been involved with every single detail, but as I look at it, that's what I think happened.
sounds good.
So yeah,
Well, Mark, thanks for jumping on, sharing your stories, sharing your opinions about things. Appreciate it. It's always fun
you
to
bet.
bring you back on and talk about stuff.
Yeah, you bet. Thanks, Isaac.
All right. Thank you. We'll see you in the next one.
See ya.
Bye.